Okay, so today we talk about the Z transform. So we have talked about the signals, we have talked about the systems and their discrete implementation we talk about. So today we talk about the Z transform. Now before we start Z transform, you have to know what is transform, why we go for transform, Z transform, any kinds of transform. There are a lot of kinds of transform. What is transform? Why you go for Z transform? You have already learned about the Laplace transform. So why these transforms are required? So transform means change of representation. So suppose something is there. Let's say this is this very object. I can see this side of the object, but I cannot see this side of the object. Now, if I want to see this side of the object, what I have to do? I have to take it, rotate it. So a rotation can be one kind of transform. So I am representing the object in different plane. So in that case, that is called transform. So let's talk about the Laplace transform. When you talk about the Laplace transform, what we have done? Now, Laplace transform any time domain system or time domain signal, when I want to make it frequency domain, which is called S domain. So I want to decompose, I want to transform a time domain signal, continuous time domain signal, to another plane, which is called S plane, Laplacian plane. So that is Laplace transform. So basically I am transforming the time domain representation to another. So any vector, let's talk about the signal. Signal is nothing but a vector. Let's talk about a vector. So I want one representation of the vector is there, I want another representation. So a time domain signal is there. I have a time domain signal like this. Let's say I have a time domain signal like this. But I want to represent this signal in another domain, which is a complex domain, which is called S domain, which is called Laplacian transform. What is complex domain? That means I am saying this time domain signal can be represented in a complex coordinate. One is real, another is imaginary axis. Then I plot this signal in this representation. Then I call it is Laplace transform. So for continuous signal, we go for Laplace transform. Now when I have a digital or discrete signal, or I can say a digital signal, or discrete signal, means time is not continuous. So I have an x of n. Here we use Z transform. Same as Laplace transform in continuous domain. What is S? S is nothing but a something j plus something. So that is nothing but a complex. So this is any S is nothing but a complex number. Similarly, Z is also a complex number. So any discrete signal, when I want to represent it in a Z plane, so Z plane again it is a complex plane. I have a real axis, I have an imaginary axis. So when I have a discrete signal, I want to represent in Z domain, which is equivalent to its called frequency domain. So time domain signal to frequency domain signal we call Z transform. Okay. So let's say what is Z transform? So the Z transform of a discrete time signal xn is defined as a power series. This is the definition of Z transform. So what I am doing? I have a digital signal which is x of n. I want to transform it in Z plane. What is the formula for transformation? N equal to minus infinity infinity x of n z to the power minus n. So if n is positive, then it is x of n z to the power minus n. If n is negative, then it is x of n z to the power plus n. So I have each sample is added up. So x of z So in z plane, representation of xn, I go to the z plane where z is a complex number. And when I do that, the new signal which is represented in z plane is called x of z. Now question is, why should I do that? That we have already said that suppose I want to see this face of this object, I have to rotate it. So rotation I have done because I want to see this face. Now why we do for z transform? Why it is required? Why we go for Laplace transform? Why it is required? It is the sake of mathematics? No. So what is that? The z transform is required when we want to analyze a discrete system, which is called pole zero concept. Similarly, Laplace transform is required when I want to analyze a system which is called continuous system. I go for the Laplace domain. Here also, if I want to make it analyze, so analysis will become easier of a discrete system when I go to the z domain. So that's why I request. So this will be easy to analyze a discrete signals or discrete system. So z domain is called frequency domain representation. So that's why I do it. I have to establish it. What kind of analysis? So at the end of the lecture, you can understand why this z transform is required. If the z transform is not there, what we cannot do. So initially I said x of z is the z domain representation of x of n. X of n is a discrete signal and x of z is z domain signal. And z is a complex variable. It has a real axis, it can real and imaginary plane. So z in any point can be represented by r e to the power j omega. Or z is a complex number which is r e to the power j omega. So e to the power j omega is nothing but a cos omega plus j sin omega multiplied by r. R is the amplitude and j omega is the rotation. Omega is the rotation. This axis is positive, this side it is negative, and when it is anti-clockwise it is called positive. So it is minus j omega means clockwise. So if it is omega is positive, this side is e to the power minus j omega. So that is the requirement for z domain. Okay. So when we use z transform, that means we want to represent a discrete signal in a complex plane which is called z domain. Now, is the when the z transform will be valid? I want to make it transform, but transform has to exist. If you see, here it is an infinite power series. X of z is nothing but an infinite power series. X of n multiplied by z to the power minus n. So it is an infinite power series. So when it will exist? If x of z is finite, unless how can I do it? How can I? When it is if it is infinite value, then what representation I can get? So xz is when we do transform, when xz is finite. That means this series, this sum has to become an finite number. That means it has to converge. Any transform, when I want to do it, it must have to be converged. Unless if it is infinite value, I cannot see anything there. So for which z value this xz has a finite value or the transform is or series is converged, that is called region of convergence, ROC, region of convergence. For those z value, so z value is nothing but a z is a plane, it is xy plane. real part, and every z has a real part and imaginary part. So there is a z plane. So I transform that discrete signal into the z plane, but that transform is only useful when that xz has a finite value, or I can say that for those z value for which xz is finite, those z value are called region of convergence in that z plane. Understand? So that is, so when I do a z transform, you have to thought about that, what the region of convergence. Now I come to the concept of the z. What is z? What is z? Z to the power minus n. You know that x of z is equal to minus infinity to n equal to minus infinity to infinity x of n z to the power minus n. So if we either z to the power, it could be z to the power minus n or z to the power plus n. When n is positive, it is z to the power minus n. When n is negative, it is z to the power plus n. So what is z? I said z is nothing but a plane, z plane. So I have an xy. What z has a two value. One is real value, another is imaginary value. So any value. So suppose I have a real axis and imaginary axis. So this point is a plus ib. So I can represent this also by a r and theta. So I can say instead of a plus ib, I can say it is r into e to the power j theta. Theta is the angle. So same way I can represent z to the power minus n. If it is let z equal to r e to the power j omega. So when I say z to the power minus n, so r to the power minus n, e to the power minus j omega n. Let's say r e to the power minus j omega. So I can say minus j omega n. Now when the n is positive, I can say r to the power n, e to the power j omega n. So e to the power j omega n, you know that it is nothing but e to the power minus j theta is cos theta minus j sin theta. Similarly, e to the power plus j theta is cos theta plus j sin theta. So z has a real value and has an imaginary value. So I can say if I want to represent a plus ib, so a real part is r to the power minus n cos omega n. Imaginary part is r to the power minus n sin omega n. If I want to represent in a polar form, so I can say r e to the power minus j omega n, when z is z to the power minus n. When z is z to the power plus n, I can say this is positive. So what is r? Basically r will determine, so what is z? Z is nothing but a cos and omega, cos and sin. So cos and sin is nothing but an oscillation. Physically z is nothing but an oscillation. Cos theta plus j sin theta, I have an oscillation. An oscillation has an amplitude and has an frequency. So omega which determine the frequency, r determine the amplitude of the oscillation. So frequency is determined by the omega and r. So I can say every z has an oscillation. The amplitude will depends on r and the frequency will depends on omega. So whether it will be decayed, how much it will be decayed, that depends on the value of r. Now all of you have heard in the Laplace transform unit circle. What is the concept of unit circle? So that's why I said plot of z to the power n. Let's say what if I want to plot. So this axis is my real axis, this axis is my imaginary axis. So y axis is the imaginary and x axis is the real axis. Now you know the stability, the system is stable if it is within an unit circle. Now, if you see the z value is less, this blue circle is the unit circle. What is the meaning? Meaning is r equal to 1. So, when r equal to 1, you know z to the power n is equal to r to the power n e to the power minus j omega or plus j omega n, let us say z is positive. Now, when r equal to 1, so I can say it is nothing but a e to the power j omega n. So, it is a constant oscillation. So, when the z value in here, this is the z plane, this entire plane is the z plane. So, when the z value is here, when the r value is equal to 1, r equal to 1, then I said any point on this unit circle, it is nothing but a e to the power j omega n. This different point means different omega. But so that is constant oscillation. So I can get a constant oscillation of different frequency if I go for the through the unit circle. Now inside the unit circle, that means r is less than 1. What is the meaning of inside the unit circle? R is less than 1. So when I say r is less than 1, that means the oscillation hasn't decayed, because r to the power n, infinite sum of r to the power n, r is less than 1. So I can say it will be decayed down. So the oscillation will be decayed down. Now if I say outside the unit circle, that means r is greater than 1. Here. So when I say r is greater than 1, then I can say the infinite series r to the power n is goes to infinite. So there is a constant gain in the oscillation. Gaining. So oscillation is increasing. The amplitude of the oscillation is increasing. If n goes to infinite, then it will be infinite series. If it is infinite series, the value will be infinite. So depending on the value of r, z, where you are present in z plane, the oscillation will be different. So when I say stable system, what is concept of unit circle? Unit circle means that if it is within the unit circle, oscillation will be decay down. So it is not self-oscillatory in nature. So it will be decay down. So I can say the system is stable. Unless what will happen? Outside the unit circle, it creates an infinite amplitude oscillation and goes, I do not know, there is no control. So that is the concept of unit circle. That is exist in S plane, that is exist in Z plane, both the cases. Is it clear? Now we go for some example in Z transform. Let us say I have a signal x of n with 0 value, that means this arrow indicates the 0 value. So x of 0 is equal to 1. So at n equal to 0, the value is 1 and this side n is positive. So I can say x of z is equal to x of 0, because I know x of z is equal to n equal to minus infinity to infinity x of n z to the power minus n. Now if you see, this signal is varies from 0th sample. So instead of minus infinity, will vary from 0 to how much value was there? How many samples are there? 1, 2, 3, 4, 5. So it goes up to 4, n minus 1. 0 to 5, 0 to 4 is 5 sample. So I can say x of z is nothing but a n equal to 0, x of 0 into z to the power 0 plus x of 1 into z to the power 1 plus x of 2 into z to the power, minus 1, z to the power minus 2 plus x of 3 into z to the power minus 3 plus x of 4 into z to the power minus 4. How many? 0, 1, 2, 3, 4. After that, signal doesn't exist, so I do not have to write down that. So I can say x of 0 is 1 into z to the power 0 plus x of 1 minus 2 into z to the power minus 1 plus x of 2 is 3 z to the power minus 2 plus x of 3 is nothing but a 0 into z to the power minus 3 plus x of 4 is nothing but a minus 1 into z to the power minus 4. So I can say x of z is equal to 1 minus 2 into z to the power minus 1 plus 3 into z to the power minus 2. This is 0 and this is minus z to the power minus 4. So that is the z transpose. Let us say another example. Here I have a both side, two sides, this side and this side both. This side n is positive, this side n is negative. So when I say the summation is varies from x of z is equal to, so n, how many samples is there? So this is number 1 sample is 1, let us say, or let us say number 1 sample is, number 0th sample is 3. So 0th sample is 3. So this side, this is minus 1, this is minus 2. I can say n varies from minus 2 to 0, 1 and 2 to 2. X of n z to the power minus n. Now write down. So for n equal to minus 2, x of minus 2 into z to the power minus 2. So z to the power 2 plus x of minus 1 z to the power minus 1 plus x of minus x of 0 z to the power 0 plus x of, I can say 1 z to the power minus 1 plus x of 2 z to the power minus 2. So that is nothing but a x of minus 2 is 2 z to the power 2 plus x of minus 1 is 1 z to the power 1 plus x of 0 is 3 z to the power 0 plus x of 1 is 1 z to the power minus 1 plus x of 2 is minus 1 z to the power minus 2. So finally it is 2 z to the power 2 plus z to the power 1 plus 3 plus z to the power minus 1 minus z to the power minus 2. So that is z transpose. And what is the region of convergence in here and here? ROC. So for which x of z is finite. Now if you see, in this case, if z equal to 0, then also x of z is infinite. If z equal to infinite, then also x of z is equal to infinite. So I can say for this case, the region of convergence is entire z plane. So entire z plane except z equal to 0 and z equal to infinite. So in this case, if you see, if z is equal to infinite, it is 0. But if z equal to 0, then this is infinite. So I can say in this case, the region of convergence is entire z plane except z equal to 0. So I have to exclude those z value for which x of z is infinite. Except all the z value in entire z plane, x of z is exist. Similarly, if I go for x of n equal to delta n, what is x of z is equal to 1? Delta n, only n equal, because why it is 1? Because you know delta n is equal to 1 if n equal to 0, elsewhere it is 0. So I can say, when I say x of z is nothing but a n equal to minus infinity to infinity x of n z to the power minus n. So when n equal to 0 only this is exists. So I can say this is nothing but a x of 0 into z to the power 0. So x of 0 is 1, z to the power 0, so it is nothing but a 1. So that's why x of n equal to delta n, then I can say x of z is equal to 1. Similarly, if I say x of n equal to delta n minus k, so same thing I will say x of z is equal to n equal to infinite minus infinity plus infinity x of n z to the power minus n. Now what is this delta n minus k? That means delta n minus k is equal to 1 when n equal to k, else it is 0. So I can say the signal is exist when n equal to k. So I can say x of k into z to the power minus k. So it is 1 into z to the power minus k. It is z to the power minus k. So x of z here is z to the power minus k. Similarly, you can do it this also. So what is un? Un is equal to 1 when n is positive. N equal to 0, 0 to positive value. N is greater than equal to 0. Elsewhere it is 0. Now it becomes a series. You can solve the series. You can get an idea. Z transform, Z domain representation of this signal. So if I give you any signal or any system, you can represent in Z domain. Impulse response is given. So let's, instead of signal, if I give you a system, impulse response of a system, let's say I said h of z, h of n, this is the system. Impulse response of a system is 2 into delta n minus 1 plus 3 into delta n minus 2 plus 1 into delta n plus 1 plus 6 delta n. This is the impulse response of Hn of a system. Then what is the Z transform? You know, delta Z transform of delta n minus 1 is nothing but a 2 into z to the power minus 1. You know that delta n minus k, z to the power minus k, plus 3 into z to the power minus 2, plus 1 into z to the power 1, plus 6 into z to the power 0. So I can say the system Z transform is 2 into z to the power minus 1 plus 3 into z to the power minus 2 plus z to the power 1 plus 6. So this is the Z plane representation. Now if I told you what is the region of convergence ROC, so if Z equal to 0, then also it is infinite. So this is Hz. If Z equal to 0, then also Hz infinite. If Z equal to infinite, then also Hz infinite. So I can say ROC is entire Z plane except Z equal to 0 and Z equal to infinite. Okay. So this is called Z transform. So there is a property, some properties of region of convergence. ROC does not include any pole. This concept I will explain at the end when I talk about the application of Z transform. Now see that for finite duration of the signal, if the signal is causal, I have already said what is the causal signal, what is the non-causal signal. That means if the signal exists only this side, n equal to, here n equal to 0, this side is n equal to 0, this side is positive. So here n is positive. Then I can say Z transform is always z to the power minus something. So that means at z, except z equal to 0, entire Z plane will be the ROC. Similarly, anti-causal signal, which is only exists this side. Then I said z to the power only plus will appear. So I can say it is ROC will be the entire Z plane except Z is infinite. Z equal to infinity. Now if it is two-sided signal, as you observe in here, here, two-sided signal. The ROC is both, ROC is entire Z plane except Z equal to 0 and Z equal to infinite for a finite duration of the signal. Now, if the signal is infinite duration, signal is infinite duration. So, x of z is a series of infinite sum. So, if it is causal signal, so if it is z to the power minus 1, z to the power minus 2 like that, and in case of anti-causal system, it will be z to the power 1, z to the power 2 like that. So, z to the power 1 plus z to the power 2 plus dot dot z to the power n for this purpose. When it will be finite? Think about it. Now, this purpose it is x of z is equal to z to the power minus 1 plus z to the power minus 2 dot 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 z to the power minus infinity. When this will be finite? Understand? So, I can say that I can find out the region of, but if it is two-sided signal, so instead of entire Z plane, it will be a ring. We will do one example for that. It will be ring. For stability, ROC include unit circle in the Z plane. Okay? So, next class I will talk about the properties of Z transform. Okay? Thank you.